In the last section, we learned how to graph a line if we knew just two pieces of information about it. We needed a starting point, we needed them to give us a point, and then we needed to know what the slope was. So there is a way that we can show this in a math equation, and it is called the slope-intercept form of a line. And it models most specifically this one, where you're given what the y-intercept is, that the point that it crossed the y-axis was right here, and then what the slope of that line is. And that equation is always going to look like this form. It's going to have y equals some number out here that's getting multiplied by x, plus or minus some other number. The m, as we talked about before, stands for slope, and with equally as much sense as m standing for slope, b stands for y-intercept. The b is the y value of the y-intercept. So the point 0b is the y-intercept. So while m and b may not make sense as standing for slope and y-intercept, I did find one website that talked about having the b stand for begin, the place where you start, and letting slope, the m, be the direction that tells you how you're going to move. So b and m don't really stand for begin and move, but if it helps you remember which number is which one is your starting place, and which one is telling you what to do from there, that's as good an explanation as any other. So let's try working a couple of problems like this. The steps that we're going to use, the first thing that you will do is graph the y-intercept, using b, whatever number is in place of the b, as the value for y. Your second step is to find two more points using the slope, just as we did in the section before, when they gave us a starting point and then we used slope to find two more points. And then finally, because the solutions to linear equations are lines, connect the dots. And something I've been doing all the way along, but I don't think I've ever actually mentioned it, is that you don't want to forget the arrows. That all of these linear equations, you've noticed when I draw the line I put arrows on the end. And what that means is that just because your graph stopped doesn't mean that the solutions stopped. There are still an infinite number of solutions extending in both directions from that line that you made. It looks like my graph paper is missing a line again. Put it in there. So, looking at our first problem, we have a slope that's equal to a negative 2/3 and a y-intercept at the point 0, 4. So I'll start by graphing the point 0, 4, which is going to be somewhere about right there on my graph. And then the slope says go down 2, because it's negative, so I'll go down 2 over 3. So there's my next point. And then down 2 more, and over 3 more. So you're running right off the edge of my graph here. Then I connect those lines. graph of the equation. Let's try another example. My slope in this case is 3, or you can think of it as 3 over 1. And my y-intercept is going to be the point 0, negative 1. So putting that on my graph, the point 0, negative 1 is right there. And I have a slope of 3 over 1. So I'm going to rise 3 places, run 1. Rise 3, run 1. Putting my next 2 points on the graph here and here. Then connecting the dots. Get this line. Two more examples. What about when y is equal to x? So this looks like it might be missing some information, since our form is supposed to say y equals mx plus a b. Well, these are both still here, you just can't see them. Remember, all variables, if they're there, have a coefficient of 1 that you just can't see. And the number that's getting added to this equation is 0. So that means that my slope, my m, is 1, or 1 over 1, if you prefer, and my y-intercept is the point 0, and since my b value is 0, it's going to be at the origin. So there's my y-intercept, up 1 over 1, up 1 over 1. My next 2 points fall here and here. Connecting the dots on my somewhat crooked graph paper. Gives me that line. And this one, I need to expand the formula first to find the missing pieces. This one says y equals 0 x's. The x term has disappeared, plus 3. So that means that this equation does have a slope. The slope is 0, meaning we've got a horizontal line. And the y-intercept is going to be the point 0, 3. So I come up here to 3 on my graph, and then every point from along that is going to not raise at all, or rise at all. The line's a little crooked. It's supposed to be a straight line. Right there, at where y is equal to 3.